Hello students, welcome to the third episode of our video example series for Circuits 1 at NDSU. This episode we're going to focus on KCL, or Kirchhoff's current law, and we're going to use it to solve this circuit. So what do we have here? We have a 3 amp current source, a 200 ohm resistor in parallel with 300 ohms in series with 500 ohms. What does KCL tell us? That any node, let's label that node 1, the sum of the currents flowing into this node or flowing out of this node are going to be 0. That sounds a little confusing, but once we start designating some currents flowing in this circuit, it'll make sense. Our end goal, let's go for VO, which is the voltage across our current source here. The voltage across the current source and the voltage across the 200 ohm resistor are going to be the same, so I'm just going to draw it in the middle of both of them. Okay, let's designate some currents. Let's say I1 is flowing downward like that, and I2 is flowing like that. We can't exactly change the orientation of our current source. We can if we want, but let's just leave it. 3 amps is flowing into that node. We know that for sure. That's always going to stay the same. Let's do a KCL at node 1. We're going to sum them. We're going to sum the currents coming out of that node because I1 and I2 are already going out. It'll make the calculation a little bit easier. Okay, we have 3 amps going into that circuit. So we would also have 3 amps negative 3 amps going out, plus I1, which is going out, so it's good, plus I2, which is also flowing out, equal to 0. These are all the currents flowing outward from that node. That's going to give us what? 3 equal I1 plus I2. Okay, let's sum them flowing inward. Our 3 amps is flowing inward, so let's just leave it. However, I1 and I2 are flowing outward, so that's the same as negative I1 flowing inward and negative I2 flowing inward, equal to 0. If you simplify this, you're going to get the same thing. It's negative 3 minus I1 minus I2, or for simplicity's sake, these are the same. It doesn't matter if you sum them inward or outward. You're going to reach the same conclusion at the end. Okay, so this actually won't be that hard. All we really need now is expressions for I1 and I2, which are really that hard. I1 is going to be what? The voltage across the 200 ohm resistor, which is VO, divided by 200 ohms. Easy. Okay. I2 is going to be similar. The voltage, VO, across 300 in parallel with 500, which is, just add them together, 800. All right, so let's write the expression. Let's plug these in here. What do we have? 3 equals VO over 200 plus VO over 800. Let's factor out VO and simplify. And what is that? That's going to be that. Yeah. And solve for VO. 480 volts. Now let's check that. How should we do so? Well, let's solve for I1 and I2. I1 over 200 equal 2.4. I2 equal 480 over 800 equals to 600 milliamp. Let's put our amperage right there. And if I'm a little running out of room here, but 2.4 plus 600 milliamp is going to equal 3. And what do we have here? Let's go over here. 3 equals 2.4 plus 600 milliamp. That's going to be 3 equal to 3. So good. Perfect. Circuit is solved. Thanks for watching.